Rich, artificial intelligence, we've alluded to it a bit in the conversation already, but it certainly has the potential to significantly impact data collection, analysis, and interpretation of real world evidence. How is AI changing the industry from a research as well as a treatment perspective?
Yeah. So, I mean, it's an area that I really, I said earlier, I think is going to change a lot of things. But in terms of processing, let's talk about that. So, artificial intelligence is enabling us to extract more from clinical records. And by that, I mean leveraging uh, unstructured data or images or pathology slides, et cetera, to capture standardized information. So that we'll call that extraction. So that's one area that artificial intelligence is really important. And we're leveraging things like large language models to make that extraction more and more efficient. And there's many companies that will focus on specific image types, whether it's lung images or MRI spine images, to be able to read those more effectively. So that's one area. Another area that we're really excited about is something we call outcome estimation. So I'll give you an example. When uh, you see a doctor, say a neurologist is seeing a patient, they will measure something called the EDSS score. Sometimes the EDSS score gives us an assessment of the disability level that a patient is experiencing, and it's used as an outcome measure in clinical trials. Payers look for this outcome measure in comparing different therapies for going on their formulary and so on. It's even used to help discern in patterns between different subtypes of MS, progressive or relapsing, remitting, et cetera. The EDSS takes a while to collect because a neurologist needs to sit across from a patient and go through a series of tests to administer it. What we have found is using artificial intelligence and these language models, we can take a comprehensive exam that a neurologist has performed with a patient, and they perform them regularly, and estimate the EDSS score, even if it hasn't actually been reported in the note or in the EMR. And we've done that using this large language model algorithm. And in doing that, we're able to estimate these scores, but now have many, many more scores, 10 to 15 times, sometimes up to 20 times the number of scores available for an individual patient's record. And these are validated. We publish all of these models and their validation in different peer-reviewed journals. But I think that changes the paradigm both for research, because you have more outcome measures, and also for clinical practice. Because what happens for the clinicians is we're starting to feed these outcome scores back, is they did everything they should have done in the exam. They just haven't, collected the result. But now they're able to go back through records over a long period of time, look at their populations, and understand the aggregate outcomes with many, many more data points along the way. So we've done this in MS, we've done it in rheumatoid arthritis with CDI, we've done it in mental health with PHQ-9, we've done it in cardiology with the New York Heart Association classification, and so on.
That's really exciting, and it harkens to what you said about the PROs playing a much bigger role. I can see that we can also reduce the burden on the patient if we're able to use AI and aggregate some of the other measures without forcing them to complete long outcome scales.